morning. Is that working? Can't tell. Oh, yeah, looks like it's working. So good morning, everyone. A little update on the Moodle page, which I'm sure you're all looking at anyways. I did update the Moodle page. I update it every week. So I've got the list of supplementary study material there. I put a module overview. I updated the module overview. And then there's the coursework one. So if you want to have a look at coursework one, it's there. We're going to talk, next week is going to be kind of a special focus on coursework one. So you're not expected to know everything yet, right? So don't panic. I've already got a few emails saying, "Dear Bob, I'm in panic mode. I'm gonna die because of coursework one." So next week it's gonna be a special focus about coursework one. Any questions before we get started with today's material? This week's material is a special focus on dissertations. So we are going to have a very exciting in-class exercise today. This is a very short presentation, or it's supposed to be very short, about what is good research. And if you do have questions or comments, please interrupt me. I don't mind being interrupted. Actually, I don't like to listen to myself talk for too many minutes in a row. And then I start picking on the audience when I want to. So some of the characteristics of good research. So good research is driven by a question or some idea, right? You have an idea in your head, you have a problem that you want to solve, you have a hypothesis that you want to test, you have a question that you want to answer. So good research is characterized by these motivations, right? And if the research is well written, then this idea or hypothesis will be very clear right in the beginning. By the way, there are some exceptions here. So there are some generalizations on these slides. And of course, there are always exceptions. You know, good research can happen by accident. Like you could be doing something and then have an accident and make a discovery, right? Everybody knows about that famous penicillin discovery, right? Penicillin was not, it was discovered by accident, right? So there are exceptions. The research that we try to do here in the school is original. So we're trying to contribute to new ideas, contribute new knowledge, right? Do things that are new. It could be testing out a new idea on an existing known problem, right? Some problems have been around for many, many years and they still don't have a good solution. Like printing, for example. Printing is still an unsolved problem, right? You have lots of problems trying to print. Trying out an existing idea on a new problem, right? So there could be an existing solution for some other problem and then trying to convert that solution to a different problem or a data or a topic. Discovering new information. a lot of research combines two ideas and tries to get the advantages of both ideas into one framework. That happens a lot, especially in visualization. Maybe reorganizing knowledge, like a meta-analysis, survey papers and state-of-the-art reports. They look at many research papers and they try to derive new knowledge, look for patterns and trends in those research papers. And that's like what a really good literature review does. So coursework 2 for this module is a literature review. And a very advanced literature review looks at several papers and tries to look for patterns and trends, or maybe something missing, right? So correcting flaws or overcoming limitations with some existing method, right? Lots of methods have limitations or flaws. Those can be fixed, right, with research. Bringing new evidence or techniques to a well-known problem, like solving a problem that's already been solved, but solving it faster. That's a very typical research direction. Or solving it with less money. That's also very common. Take an existing problem, solve it with less money. Or fewer resources, right? Fewer people, maybe. Less hardware, less memory, right? Very common. Applying knowledge from one discipline to another. So sometimes we'll take a mathematical theory that's very maybe known in the world of mathematics and bring it into the field of computer science, right? Implement an existing theory. Or proving a well-known conjecture or solving an unsolved problem. I mean, these are my favorites, right? Solving an unsolved problem. That's a favorite research topic. Right? If you can solve an unsolved problem, that's fun. Good research is contextual. That just means you've done some homework and you know how the problem you're trying to solve relates to the previous attempts at trying to solve the same problem or a similar problem. Right? So it builds on the current knowledge base and says, okay, we're trying to solve this problem, and here are the attempts that have already been made by other people to solve this problem, and this is what they look like. So it looks at what has been done before. This is kind of the definition of research, isn't it? It's checking what has been done before on your problem or challenge, right? And then demonstrating that you have done your homework and you know what's been done before, right? That's essentially very close to the definition of research. If you just say, oh, I've solved this problem, and you don't know what's been done before, that's not going to be considered good research. And then good research is creative, right? We said it introduces things that are new. And then the question is, how do you think of something new? This is a tough question, by the way. How do you think of new problems to solve? Has anybody ever thought about this? How do you think of new things, new problems to solve? Anybody ever thought about that? It's challenging, right? You're asked to do something brand new that nobody else has done before. How do you figure out like what's new? Anybody have any ideas about that?
Maybe current trend like AI stuff with social impact on AI. You draw some like brainstorm and try to figure out that.
Brainstorming is a good idea. Looking at research papers themselves is a good idea. Research papers have a future work section at the end, right? So they're going to point to some unsolved problems. Another, like, just idea is to listen to people talk. I know that sounds strange, but if you just listen to people talk, you'll get ideas. And there's a special kind of talk that produces very good business ideas. Maybe not research ideas, but certainly business ideas. If you listen to somebody complain, right? Complaints are often good inspirations for business ideas. Or when something breaks, right? Anyways, that's a big topic. Like we can't, there could be a special lecture just on how to think of new things. That could be its own lecture. Good research can be generalized. So if you propose a solution to a problem, if it's a good solution, it can be applied to other problems and adapted to other situations. Good research is reproducible. So in other words, someone else can reproduce your experiment or your software or whatever it is you did. If you think about it, what is truth, right? We have this idea in our head that some things are true and some things are false. And some things are relatively true and some things are absolutely true. It's hard to find those. But how do we define truth? Anybody ever think about that? I thought about that a lot. Anyone else think about, like, how do you define what is true?
I mean, in math, you can have some axiom. You base on axiom, you can prove something true.
In mathematics, right, there's a set of rules, and you agree on the set of rules, and you say this is the truth. How about in a more general sense, though? Like, any ideas how you might, like, discover the truth in a more general sense that's not just theoretically pencil and paper? Anybody think about this? We all have this idea in our head that some things are true, don't we? Well, I'm glad that we're talking about this. They have to be reproducible. That's very closely related to the truth, reproducibility. So if I tell you, oh, I'm going to drop this apple and it's going to always fall down and hit the ground, right? The only way you know that's true is if you can reproduce that result. So it has to be reproducible. So if somebody's doing research in Japan and they say this is true, I have to then be able to say in the UK, okay, I need to be able to reproduce that result in the UK, and then it becomes true. Right? If somebody drops an apple in Japan, I have to be able to drop an apple in here and reproduce the results. Imagine if my apple went up, then I would say to the Japanese person, hey, what you wrote isn't true, right? So it's about reproducibility. This is how the truth spreads, by people being able to reproduce things. So if you do something that's not reproducible, you're not really going to contribute to truth. You know, if nobody's going to believe you. Like, if nobody can reproduce what you've done, then nobody's going to believe you, right? It's not going to be automatically true. So, good research is reproducible. Good research is ethical, moral, and benevolent, right? It doesn't exploit people, right? It's to the benefit of society. It's to the benefit of nature, and so on. It has positive impacts on society and culture at large. Right? You can have bad research, right? That's not very good and not very ethical and moral, and so on. Good research is relevant. So there is some research that is pure research, right? Research for its own sake, but the ultimate goal is to have a wider impact beyond the world of research that contributes positively, right? That has a positive impact somehow, right? A lot of research in computer science solves real problems, problems that can be applied outside computer science to society and the economy and the culture at large, right? How you can also ask yourself, how important is the problem you're trying to solve? Who might benefit from the results? This is a big question. So who benefits from your research? If you can answer that question, then you know it's relevant, right? And can you, is there a way to take the research and make it, extend it beyond just the School of Computer Science, for example? Good research is usually collaborative. It's very rare that research is done in complete isolation. It's very rare. It can happen, but it's rare. You'll need to do individual work for your dissertation, but you still also need to collaborate. You need to collaborate with your supervisor. You might need to collaborate with other people in the school. You might have students that you're working with. You might have participants in a human-computer interaction study. You might be collaborating with a partner, like a member from another school or an industry partner. So usually there's some collaboration involved. And usually there's some sponsor involved too, right? Somebody that's helping you do the research. Okay, so today's workshop task is to look at some dissertations, right? So on the Moodle page there are two previous dissertations. We are going to form groups like we did last week. We're going to review Bob's project guidelines, like right now. Then you're going to browse the previous dissertations as a group and fill out an evaluation form about those dissertations. You are assessing them. You're looking at them and you're giving your opinion about how good or not good they are. Maybe you can find some imperfections. And then afterwards we'll show you that we'll discuss the results of your evaluations. So let's start with number 2, which is review Bob's guidelines. We'll do that right now. Bob's project guidelines. So those are on Moodle, right? Bob's project guidelines. This is the evaluation form for the dissertations, those are the 2 dissertations. Any questions about good research?